Hi, and welcome to my video on the composition of inverse functions, and we're still doing the linear functions. Number one, f of x equals 2x. Again, it's a linear because the degree is 1. Find the f to the negative 1 of x. That means find the inverse of x. So we change the f of x to a y. We interchange the y to an x to a y, and we solve for y. So we divide by 2. 2's cancel, so y equals half x. So the f to the negative 1 of x is equal to y is the f to the negative 1, so it's a half x. So the f of x is 2x. The inverse is a half x. The opposite of multiplying by 2 is dividing by 2. So now, since we have both of them, find the f of negative 1 of x. So that means this is a composite. So we're putting f to the negative 1 of x, which is half x. So there's a half x. So we fill in the inside first. Now we take a half x and sub it into f. So that means we have 2 and a half x goes into x. So we have a half x. So 2 times a half is 1, so we get an x. If a function and its inverse, we do the composite of each one, either way, then we will get x. So let's find the f of negative 1 of f of x. So that means the f of negative 1. So the f of x is 2x. And so now we take 2x and sub it in the inverse. So the inverse is right here. So that's a half. And this is the inverse. So we put 2x in here. We get that. And a half times 2 is 1. So we get an x. Again, if you have two functions which are the inverse of each other, to do their composites, we will always get the original number back, which is x. And to explain that, so if we do the f of, say, 5, the f of 5 is 2 times 5, which is 10. So that means the f of 5 equals 10. So that's x is 5, y is 10. So when we reverse it, then its inverse, the inverse of this ordered pair is 10 comma 5. So if we take this and put it into the inverse, so the inverse of x is a half x. So 10 is the inverse of 10 is a half of 10, which is 5. So we start out with 5. So when we notice I took a 5 and I worked it out to be a 10. So when I do the inverse, the 10 should give me a 5 back. So that's what this is doing, and this one is doing. No matter if two functions are the inverse of each other and I do their composites, no matter which way I do them, like this way, putting the f to the negative 1 in the f, or putting the f of x into f to the negative 1, we'll always come up with an x. Now, let's graph each of these to see what they are. The f of x, this is x and y. So the f of x is 2x. So if x is 2, y is 4. If x is 1, y is 2. If x is 0, 2 times 0 is 0. And the f to the negative 1, f to the negative 1 is a half x. So if we take x and y, so if we put a 4 in, half of 4 is 2. If we put 2 in, a half of 2 is 1. If we put a 0 in, a half of 0 is 0. So the f of x, we have when we do this, we're reflecting in the line y equals x. So we're reflecting in this line right here. So this is the line y equals x. So when you take the f of x and plot the ordered pairs, 2, x is 2, y is 4. X is 1, y is 1. X is 1, y is 2. X is 0, y is 0. So when you draw this line going to these points, so this is the f of x. So when you do the reflection, which is changing the ordered pairs or working out this, so the reflection of 0, 0, 0, 0, reflection of 1, 2 is 2, 1. So x is 2, y is 1. And the reflection of this one right here is 2, 4. So this is reflection. It's switch the x and y. So that's a 4, 2, which is right here. So if I draw that inverse in red, then it's doing this. So this is f to the negative 1 of x. So this line, f of x, has a slope of a half with a y-intercept of 0. This line has a slope of 1/2 and with a y-intercept of 0. So there's this reflection. Just wanted to show you about the linear. And again, the red one is the reflection of the black one. Okay, let's have another go. Do some more. What about if the h of x is 1/3, negative 1/3 x plus 2? Find the h of negative 1, this is inverse. Again, it's still a linear because x is, the power of x is 1. Linear is degree 1. So the f of x is a y. We switch the y and the x's. Y becomes x, x becomes, now I solve for y, so I move the 2 over and make it negative. Now I multiply, I want to make the y multiply by the reciprocal of negative 1/3 is a negative 3, so I multiply both sides by negative 3, so I get a negative 3x plus 6 equals, they cancel, and I get a y. So the inverse is negative 3x plus 6. So the h of x is a negative 1/3 x plus 2. So its inverse is 1/3 x plus 6. Now let's show that the h of negative 1 of x is x. So the h, so h to the negative 1 of x is a negative 1/3 plus, sorry, negative 3x plus 6. And now we're going to sub that into h. So we get negative 1/3, negative 3x plus 6 plus 2. So if I keep working that out, I should come up with an x. Negative 1/3 times negative 3 is x. Negative 1/3 times 6 is negative 2 plus 2. And you can see they cancel, so I get an x. Again, anytime you take a function and find its inverse, then when you do the composite, you should have an x. And the same way if we do the composite in reverse. So now I'm going to put the h of x in. The h of x is negative 1/3 x plus 2. So now I'm going to sub this into right here, because this is the f of negative 1. So that's a negative 3, negative 1/3 x plus 2, and we have a plus 6. Again, h of x is right here, so we're subbing that into this x right here, in the f to the negative 1. So negative 3 times negative 1/3 is x. Negative 3 times 2 is negative 6 plus 6. And they cancel, and I get an x. So I'm just showing you that a function and its inverse, when we do the composite, of each one, no matter how we do it, we will always come up with an x. Here's a little different question. A has the coordinates of negative 3k minus 1 and n plus 1 divided by 4. So this is the x and this is the y, and the A. Point B is n negative 3, n minus 3 over 8, and k minus 7. So this is the x and the y. So if A is reflected in the line y equals x, find the coordinates of A and B. So that means that x is equal to y because they're reflected in this line. That means y is x. So x is y and y is x. So that means that if you take A, which is 3k minus 1, and B is n minus 3 over 8, and k is negative 7, that means x is y and y is x. So that means that this 3k minus 1 is dx here, is the y over here. So that means that negative 3k minus 1 is k minus 7. And also that the y here is the x here. So that means n plus 1 over 4 is equal to n minus 3 over 8. So x is switched. So this, whatever this is value here, is right here. So we make these two equal. We make those two equal. We solve it. 3k minus k equals negative 7 plus 1. 2k is negative 6 divided by 2. That means k is negative 3. And we solve this. We can cross multiply. We can do a common denominator, but it's easier to cross multiply. So 8 times n plus 1 equals 4 times n minus 3. 8n plus 8 equals 4n minus 12. 8n minus 4, that's an n, huh? Not an x, equals negative 12 minus 8. 4n equals negative 20. Divide by 4, and n is equal to negative 5. So we have what k is. So let's take point A. A is 3k minus 1 and n plus 1 over 4. So let's continue. If we take k is negative 3, so 3 times negative 3 minus 1, and n is negative 5, so negative 5 plus 1 over 4. Let's continue. That's a negative 9 minus 1. Negative 9 minus 1 is negative 10. And a negative 5 plus 1 is negative 4 divided by 4 is negative 1. Now, let's take B. B is n minus 3 over 8 and k minus 7. So B, n is negative 5, so negative 5 minus 3 over 8. And k is negative 3, so it's a negative 3 minus 7. So B is, that's a negative 8 over 8, which is negative 1, and that's a negative 10. So notice, because they're reflected, the coordinates of A are negative 10, 1. So B is reflected, so is negative 1, 10. So there's the value of k and the value of n, and we reflected it and made it that the reflection is x and y becomes y and x. So that's just working out some extra questions on the composite of the functions and doing a bit of reflection. So that brings us to the end of that video. And again, if you like my video, click the like button. If you want to subscribe to my channel, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that I have on my YouTube channel, which is one word, Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.